Welcome back to the Before AGI podcast. Thanks for joining us.
Yeah, great to be diving in again.
This is episode 2 of our series, The Minds We're Building. And today, we're tackling something really fundamental.
We're looking deep into probably the most, let's call it vexing operational risk with modern AI, the confident error.
Right, the hallucination.
Exactly. And it's not just some, quirky bug. It's actually a really profound window into how these systems think, or maybe how they don't think like we do.
Okay, so our mission today.
To really unpack why this happens, what it tells us about the difference between human intelligence and machine processing, and maybe most importantly, why anyone using AI needs to fundamentally rethink trust.
Yeah, because the moment you start treating an LLM like it's some kind of oracle, some definitive source of truth, well, that's when you hit the wall, right? The hallucination wall.
You absolutely do. And, understanding why it's so hard to fix starts with getting this core difference clear. We need to stop framing AI as just a less capable version of us.
Right, the sources we looked at really emphasize this.
Precisely. Think of that analogy.
Right.
Human intelligence, shaped over millions of years, it's like that versatile Swiss Army knife. We handle ambiguity, context, learning new things.
Yeah.
It's flexible.
We adapt, we understand nuance.
Yeah, but current AI, these LLMs, they're not Swiss Army knives. They're more like incredibly specialized power tools.
Super powerful at specific things like generating code or translating, yeah.
Exactly. Astonishingly powerful. But take them outside that narrow task. They become brittle. They lack, self-reflection, the ability to genuinely believe something is true.
And that lack of belief, that's kind of the crux of it, isn't it?
It really is. When we talk about intelligence, the humankind is so broad. General purpose learning, consciousness, feelings, self-correction based on reality.
But the machine definition we're using now, it's much narrower.
Much. It's strictly algorithmic. It's about achieving specific defined goals by following statistical patterns it learned. It's purely about output generation, not understanding the input or believing the output.
So no consciousness, no feelings, no actual beliefs about the world.
None whatsoever. The analogy that keeps coming up is the parrot. A brilliant parrot that can mimic human language structures perfectly, maybe even write a beautiful poem, but without understanding a single word of it.
Or like a super advanced calculator?
Right. A calculator that can do incredibly complex math on words based on patterns, but doesn't know what numbers or indeed words actually mean.
Okay, but then how do we reconcile that with the performance? I mean, GPT-4 scores in the top 10% on a simulated bar exam. It writes essays that sound incredibly human.
That's the paradox, isn't it? It feels like understanding because the performance is so dazzling.
So how does it do it if it doesn't understand?
It all comes down to advanced pattern prediction. Nothing more, nothing less. It's ingested, literally, billions and billions of words, sentences, documents.
From the internet, books?
Everything. And it's learned the statistical probability of which word, or even part of a word, is most likely to follow another in any given context.
So it really is just like a superpowered autocomplete.
That's fundamentally it. An extremely fast, gifted autocomplete operating on a massive scale. It constructs outputs based purely on what's statistically plausible.
It looks like intelligence, but it's probability calculation.
Precisely. And this gap, this disconnect between the amazing performance and the purely predictive mechanism, that's the birthplace of the confident error, the hallucination.
Okay, so let's get into that. If its job is just predicting the next most probable word, how does that inevitably lead it to just make stuff up?
Well, it leads directly to what we're calling hallucination, an output that sounds perfectly plausible, maybe even authoritative, but is factually wrong or just entirely fabricated. And crucially, this isn't like a software bug we can just patch. It's an inherent consequence of how it's built.
And the consequences can be serious. We're not talking about minor errors sometimes.
No, absolutely not. The stakes are high, especially professionally. The sources highlighted that famous case, the attorney.
Oh, the legal brief one. Yeah.
Right. Submit a brief citing multiple court cases, names, citations, the rulings that were completely made up by the AI. It sounded perfectly legitimate.
Until someone checked. And then judicial sanctions, a huge breach of professional trust.
A disaster. And it happens in less critical areas, too, showing that lack of grounding. Like the example of the chatbot asked about some niche academic topic.
Instead of saying, I don't know.
Just confidently invented the title of a PhD dissertation that never existed. Made up the author, the university, everything. It was optimizing for sounding helpful and knowledgeable, even if that meant fabricating.
Okay, so for the developers, the tech professionals listening, Understanding why it fabricates is key. It's not just about prompt engineering, it's deeper. What are the root causes?
We can break it down into maybe 3 core reasons based on the materials.
Mm.
First, it's the architecture itself. LLMs are predictive systems, not truth-verifying agents.
Meaning their main goal isn't truth.
Correct. The model's core mathematical goal is usually something like minimizing the difference between its predicted next word and the actual next word in its training data. There's no built-in reality check module.
So it gets rewarded for sounding coherent, for flowing well, based on all the text it's seen.
Exactly. Coherence over veracity. If it sounds like a plausible answer based on its statistical model, mission accomplished. Whether the capital of Narnia is Paravel or something else doesn't factor into its core function.
Got it. What's the second reason?
This one's really important. The training incentives. Standard ways we train these models actually reward guessing over acknowledging uncertainty.
Wait, hold on. If developers know this leads to fabrication, why train it that way? Why not incentivize saying, I don't know?
That's a really fair question. And the answer usually comes down to, well, usability and user experience. Imagine an AI assistant that constantly replied, sorry, I don't have enough information, or I'm not sure.
Wouldn't be very useful for brainstorming or drafting, yeah.
Exactly. Users want answers. They want generation. So developers tend to optimize for, let's say, high utility, high completion rates. The model implicitly learns that providing a plausible sounding answer, even if wrong, is often better or less penalized than just stopping cold. Confidence gets rewarded.
Huh. So it learns to bluff, basically, like a student guessing on a test rather than leaving it blank.
That's a decent analogy, yeah. It optimizes for generating something that fits the pattern. And the third reason ties into this: the lack of grounding in reality.
No.
If you ask it about something well-documented, like the moon landing, it has tons of data points to draw from to make statistically sound predictions. But ask it about something fictional, like Narnia, or something too new or too niche, or maybe even a future hypothetical.
Like that made-up legal case from 2050.
Right. It has no factual anchor.
Oh.
It can't check against reality because reality isn't explicitly encoded. So what does it do? It falls back on its core function. Predict the next most likely word based on the structure of similar requests. It generates text that looks like a legal ruling or sounds like an answer about Narnia, because that's statistically probable, even if it's pure invention.
Wow. Okay, so this behavior, this tendency to hallucinate, it really reveals something quite profound about the AI mind, doesn't it? Its cognition is, well, it's fundamentally divorced from truth.
That's a stark way to put it, but yes,
Yeah.
it operates on mathematical likelihoods derived from patterns and data, not on conviction, belief, or verification against an external world.
And critically, it can't reason or reflect on its own output.
Absolutely not. A human might say something, then think, wait, does that sound right?
Okay.
Go check. The AI, it just calculates the next token, then the next. It has no mechanism to spontaneously doubt itself or realize it's generated nonsense.
Which leads to this really interesting idea, this innovation paradox you mentioned. Is it possible that the very thing that allows AI to be creative and infer connections is also what makes it hallucinate?
That's the provocative question researchers are grappling with. Some analysis suggests exactly that. The flaw might be inseparable from the creative strength.
How so?
The argument goes something like this.
No.
A model that never hallucinates, that is perfectly factual all the time, might be a system that can't infer, can't imagine, can't make novel connections, or generate truly creative text. To get that imaginative leap, maybe you need a system willing to operate slightly outside the bounds of known facts.
So perfect factual accuracy might actually kill the creativity we find so useful.
It's a potential trade-off, yeah.
Yeah.
A very difficult one. Which brings us squarely to the alignment struggle.
Trying to align these probabilistic prediction engines with objective truth.
And the expert consensus seems to be that perfect 100% truth alignment. It's likely unattainable with current architectures because you're fighting against the fundamental nature of the machine.
So engineers are mostly applying patches, trying to manage the problem rather than solving it at the root.
Pretty much. They're using tactical fixes to try and suppress the symptoms, the hallucinations, but the underlying predictive engine remains the same.
Okay, let's talk about those fixes. What are developers actually doing right now to try and mitigate this? What are the common techniques?
Probably the most talked about one is RAG retrieval augmented generation.
Origi, right, like giving the AI footnotes.
That's a good way to think about it. You essentially force the AI to first consult a specific trusted database or a set of documents before it generates its answer. So if you ask about, say, your company's latest internal policy update, the RIG system makes it look up the actual policy document first.
Okay, so that helps with the grounding problem you mentioned. It gives it a specific anchor.
It does,
Yeah.
but it doesn't fundamentally change the AI's core predictive nature. It still has to interpret that retrieved information and decide how to phrase the answer based on its predictive logic.
And the retrieved info itself could be flawed, or the AI could misunderstand it.
Exactly. REG introduces its own complexities and potential failure points.
Hmm.
It helps, often significantly, but it's not a silver bullet.
What else? We hear about chain of thought prompting.
Right. That's about making the AI show its work. You prompt it to lay out its reasoning step by step before giving the final answer.
What does it help?
Often, it improves accuracy because errors in the reasoning process become more obvious, both to the AI potentially and definitely to a human reviewer. It forces a more structured output.
And then there's just good old-fashioned fine-tuning with human feedback.
Absolutely. Reinforcement learning from human feedback, RLHF, is huge. Humans rate the AI's outputs, penalizing incorrect or nonsensical answers, rewarding good ones. This steers the model over time.
But again, these are all managing the output.
Yes, that's the key takeaway from the sources. RA, chain of thought, RLHF, they are brilliant engineering efforts to suppress hallucinations, but do not address their fundamental cause. They constrain and guide the predictive engine, but they don't change it into a truth engine.
So, truly overcoming this, getting AIs that are reliably truthful, that requires a bigger leap.
It seems so. The path forward likely needs fundamentally new architectures. Things people are researching now, like maybe integrating symbolic logic systems, which do operate on rules and truth values, alongside the probabilistic LLMs.
Or giving AIs some kind of internal memory or a better feedback loop so they can learn from mistakes more robustly.
Precisely. These are deep research challenges, way beyond just tweaking current models. We're talking about potentially different kinds of AI minds altogether.
Which puts our current situation into sharp focus. We have these amazing power tools, incredibly fast, capable of incredible generation, but built on a logic that isn't inherently tied to truth.
And that understanding has to guide how we use them.
Okay, so let's bring it home for the listener. Given everything we discussed, the predictive nature, the training incentives, the limitations of current fixes, what's the absolute essential takeaway, the strategic imperative for professionals, for developers, for anyone relying on AI output.
The message has to be crystal clear. Treat AI as an assistant, not an oracle.
Assistant, not oracle. I like that.
The second you treat it as the final source of truth, you're setting yourself up for failure and potentially serious consequences. Every single output, especially anything involving facts, figures, or claims about the world, needs rigorous human oversight and verification.
Because the hallucinations aren't just occasional bugs, they're baked in.
They are an inherent risk, a feature of the current design, not a temporary glitch we'll patch away next month. So that human judgment, that final check, it remains absolutely crucial for accuracy, for safety, for ethics.
So embrace the power, use it for drafting, brainstorming, summarizing, coding assistance, but never, ever skip the human validation step.
That's the responsible path forward. And, if we get that balance right,
Yeah.
the real revolution isn't waiting for perfectly flawless AI, because that might never fully arrive with these architectures.
The revolution is where?
It's in how we use these powerful, flawed tools, using their capabilities to fundamentally reimagine our approach to knowledge, creativity, and collaboration. It's about that synergy human judgment guiding machine speed and scale. That's where the true potential lies.
That's a fantastic thought to end on. Finding that synergy, understanding the tool's limits and its strengths. Hopefully this deep dive has given you, the listener, a clearer framework for doing just that.
I certainly hope so. Thanks for exploring why the minds we're building still sometimes get things wrong.
Absolutely. If you want to keep digging into the state of AI, its capabilities, its limitations, be sure to subscribe to the Before AGI podcast. And for more hands-on tutorials, deeper technical insights, and practical guides for working with these tools, check out the YouTube channel. That's Ian Ochieng AI, spelled O-C-H-I-E-N-G, Ian Ochieng AI.
Great stuff there.
Definitely. Thanks again for listening, and we'll catch you on the next deep dive.